All right. Today we are here on 12.1. We do have a Delta Math again coming at you. And
Well, we skipped a bunch. We skipped what?
Well,
6 units? 0.6. Because it goes 11.4 and 11.5.
no, see, look, it's 11.1 to 11.4. Now we're here in 12. So here we go. All right. So chapter 12 has to do with three-dimensional figures. And so we take our two-dimensional figures that we have been working with, like trapezoids and polygons, and now we're turning them into polyhedra. So today we are learning about polyhedra, and we want to be able to identify and describe and classify polyhedra. So here we have some examples of polyhedra. Kalia. Here we have a couple examples of polyhedra, and these three things are not polyhedra. What do you think is the difference between polyhedra and not polyhedra?
3D and not
rounded. Yeah, exactly. So polyhedra all have flat sides. Everything is flat, okay? And it's sort of combined into this three-dimensional shape. So our tissue box is an example of a polyhedra, but all the faces are made of two-dimensional rectangles, okay? So a polyhedra is formed by polygons, like squares, rectangles, triangles, trapezoids, all plane figures. These not polyhedra shapes they're rounded. They've got circles involved, okay? And a circle is not a polygon because of its rounded edges, okay? So when we talk about a polyhedra, we have some words, some vocab we want to make sure we understand. This is a polyhedra that has faces. There's a top, there's two sides, there's a base, and there's a front and a back. So this polyhedra here has 6 faces. And those faces are all the flat sides, like our tissue box. Any of these flat sides is going to be a face, okay? So they have 6 faces. Where 2 faces come together, we get an edge. That says edge. I don't know if you can really read it, but it does say edge, and that's what, yeah. Vertex, yeah. So where our edges come together, we get the vertex. All right, so I know that didn't copy over great, but there we go. So we get so it has vertices. On this particular polyhedra, we have 1, 2, 3, 4, and then 5, 6, 7, 8 vertices, okay, on that particular polyhedra where all the edges come together, where they meet. So a couple of vocabulary words here. We have 2 different types of polyhedra. We have prisms and we have pyramids. And it's important to be able to recognize the difference. So a prism has 2 congruent bases, which are connected by rectangles. So all prisms have bases that are connected with rectangles. So for instance, I could draw a triangle, and then I'm going to draw a rectangle basically a line up from each of those. I'm going to draw, this is not a great, there we go. Let me do it that way. My line's got not straight, there we go. And then I can connect those 3 points with another triangle. This is an example of a triangular base pyramid. I don't know, it's very difficult to draw. They've drawn one down below. You can see it there already. But you can see that there's a top and there's a bottom, and there are two bases that are congruent. So we have congruent bases that are triangles in this case. Triangles, there we go. And the faces are all rectangles. So we get this face, there are three faces, and they're rectangular in shape. So prisms have to have rectangles connecting them. A pyramid has one base, only one base. And the lateral faces, and by lateral we mean the sides, okay, the lateral sides, are all triangles, which meet at a single point called the vertex. Okay, so we have to look at all of these lateral faces and determine, is it a prism or is it a pyramid? And so we want to look below and classify and name each. So first of all, letter A here, is this a prism or a pyramid? Clearly a pyramid. All right, it is a pyramid, and if I wanted to name this, I want to describe the base. And so what is the base here? A pentagon. All right, it's a pentagon base, and so we would call this a pentagonal base pyramid. And that is its name, a pentagonal base pyramid. What'd you say? Nope. All right. And then if we look at letter B, how many bases do you see? How many congruent bases? Yeah, we have the front. In this case, it's sort of laying on its side, if you will. We have a base here, and this has two bases. And what are the bases? What shape are they?
Hexagon.
Hexagon. All right. They are hexagons. And you can see that all of the lateral faces, all of the sides, are rectangular in shape. So it's really important that you can recognize we have rectangles connecting those bases. So is this a pyramid or a prism? Yeah, it's a prism. And so since it's a prism, and we're going to describe it using the base. So this is a hexagonal base prism. And that's his name, hexagonal base prism. Trying to see if I have, oh, look at that, I do have one. So that's it in 3 dimensions there. There's the hexagonal base prism. So you can see all the rectangles that make it up there. All right. Letter C, how would you describe this? Is letter C a prism or a pyramid? Prism. And what shape is the base? Triangle. And so we would call this triangular base prism. Triangular, A-N-G-U-L-A-R. Triangular base prism. All right, very good. And D, pyramid or prism? Pyramid. Pyramid. I have one here. This is a pyramid. And what's its base? Square. Yeah, it is a square. So you can see it right there. Do take a minute. And here is the square base pyramid. Okay, and again, it comes to a single point called the vertex. And each of these lateral faces are triangles. So all the triangles come to that single point there. So really quite interesting. All right, so prisms and pyramids. That's fantastic. Pretty easy. Let's turn the page. So example 2, what type of cross-section is formed if sliced horizontally? I'm going to encourage you to read carefully on these problems because they're going to change the directions on you. So you want to pay close attention on these type of questions. They're pretty easy. A cross section is if we take our shape, and so I have my same matching shape here. So it is my hexagonal based prism. Okay. Now it's standing up on its base here in this picture. My question, a cross section is if we cut it and slice it into two pieces, okay? So in this case, the first one, I'm going to slice it horizontally. So if I cut through my figure, if I were to cut it, what shape would you see if you were to look at it? But what shape is it? Is it a square? Yeah, it's a hexagon. Oh, it's a pentagon. You're right. So it is a pentagon because it's a pentagonal base. You're exactly right. So imagine if I were to take this one, my figure is a hexagonal one, but all I'm doing is slicing through it and cutting it into two pieces. So now if you take the top off and look at the shape that you see, what shape is it? On this one, it's, yes, on this one's a hexagon, but on this one it is a pentagon. So pretty easy. Now here, this is the square base pyramid. Yeah, and again, if I were to slice horizontally, yeah, it is just whatever the base looks like if we go horizontally, most cases. Okay, so this one, we would see a square. And then triangles. Yeah. Now let's slice this one vertically though. If we were to slice this one horizontally, we'd get a triangle shape. Yeah. But let's slice this one vertically. If I were to slice this vertically and cut it, what shape, what is this figure, by the way? It's a cylinder, yeah. Yeah, it's an interesting question, though. If I were to cut my cylinder vertically, so I'm slicing straight down this way, what shape do you see? What are you looking at? A rectangle. Yeah, it is kind of interesting. So yeah, you would, if you were to slice this thing, you would slice off a piece and it would be a rectangular shape there if we went vertically. So be careful as you're reading through these questions. They are going to ask you some different things. They're going to say, is it like if it's perpendicular to the base or parallel to the base? Okay, so read carefully. So when we have these three-dimensional figures, we need to be able to calculate the surface area. And of course, if we're trying to find the surface area, we really just need to add up all the areas, A-R-E-A-S, of each face. And so what you're looking at here, we want to add up all the areas of each face. This, do you know what the word for this is called? What this thing here is? Have you seen one of these before? It's called a net. But I think that it's really like a pattern, okay? So the mathematical word is, we call it a net. I have no idea why it's a net. But you can imagine if we were to cut this shape out on these solid lines, and then you would fold up this right-hand side, and you'd fold up the left-hand side. On the dotted lines, you make a fold, and you'd put it together. What shape does it become? A triangular base prism. You're exactly right. So you can imagine here, this is my sort of triangle side. And so I have the base here, and I'd fold up my little triangles, and then it wraps rectangles, and those would be the faces of it. So a net is basically like a pattern that creates this three-dimensional shape. And so you have to have a little bit of imagination. But we want to find the areas of these faces, and if we find all those areas, then we can add them together. What is the area of this little rectangle here? How do we find the area of this? How'd you get 195? It is, yeah, 15 times 13. It is base times height here. 15 times 13 is 195. So it's nice if you draw the picture. I'm just multiplying 15 times 19. What about this rectangle that happens to be right here?
9 times.
It's 9 times, what's this length?
15.
15. All right. So 9 times 15 is 135. Okay. And then what about this rectangle? It's got
15 times 15.81.
Yeah, again, we have another 15. Why would you divide by 2?
It like wraps around, doesn't it? I thought like you said like. Why would you do?
You wouldn't divide by 2. It's just a rectangle. We're finding the area of the rectangle. And that's 15.81 times 15 again. So we get 237.15. And then I have 2 bases here, which are triangles. How do we find the area of those triangles? What's the formula for area of a triangle? 1/2 base times height. This is not Pythagorean theorem. Okay. All right. So when I look at these 2 triangles, what do we need to know here? We need to know which is the base and which is the height. What's really important about those 2 measurements? So, but I have a triangle here. I have a 13, a 9, and a 15.81. What is the base and what's the height?
9 is the base.
Okay. 9 is the base and 13 is the height because they are perpendicular to one another. So you need to be very careful here. So that's going to be 1/2 13 times 9.
What if one side is taller than the other?
Base and height must be perpendicular to each other. So you need to make sure that they go in opposite direction. You'll notice we didn't use the 15.81, so we had to choose wisely. All right, 1/2 13 times 9 is 58.5. So 58.5, and they're both 58.5 because 2 congruent bases. So how do we find the total surface area? Add them all together. Pretty easy. 195 plus 135 plus 237.15 plus 258.5. So you'll notice I used some multiplication there. And so we get 684.15. I do encourage you to make a picture because I think that's helpful. Okay. All right, questions on that one? No? Okay. Then let's do just letter B, I think. Oh, and maybe D. I don't think we know. We'll see. All right, so here, what shape is this going to fold up into? You'll know it is a pyramid. Very good. So the base is a square, and then these sides would sort of all fold together, and it would turn into our handy square base pyramid here, because all the sides just sort of fold up to a point, okay? So this is a square base pyramid. And if this is 7.8, what is also 7.8? Thank you. I'm answering my own questions now. Let's see. So how do I find the area of the square? 7.8 squared. All right. And so we get 60.84. And then all of these triangles are the same. And so again, I need the area of a triangle is 1/2 base times height. So if I'm looking at this triangle, what's this pink base here? Also 7.8. And what's the perpendicular height?
7.2.
7.2. And they've labeled it to the side here. So 1/2 7.8 times 7.2 will give me my area of one of them. So 0.5 times 7.8 times 7.2, and I get 28.08. And that's what each of these triangles is. So how am I going to find my surface area? Yes, plus 4 times 28.08, because I have 1, 2, 3, 4 of those. So 60.84 plus 4 of the thing above. And I get 173.16 for the surface area. So surface area is just adding up all the faces of our polyhedra. And I don't think we need to do the open top box.
No, it's just.
Yeah, it's just finding all the rectangles. So I think we're okay. Do you have any questions for me? No? All right, fantastic. Then you guys go ahead and get started on the delta math. Yeah.
That was bad. Yeah, that's